Okay, so now we're going to take a look at something that is a little bit different. We're going to look at something called type 1 and type 2 error. Type 1 and type 2 error occurs when you have completed your hypothesis test. You've done everything you need to. You've gone through all the steps. You've done all your calculations. And something goes wrong, but you aren't going to know it. So one of the things that we want to think about when we think about a hypothesis test is we want to think about hypothesis tests in an analogy to a court case. We want to think about our null hypothesis as a defendant. So the null hypothesis is being defended, and we are going to presume that it is true unless we can find enough evidence using our data to prove that it is false. Just like in a court case, the defendant is presumed to be innocent unless they can be proven guilty. And that's the same thing with a hypothesis test. We assume that the null is true unless we have enough evidence to say that it is false. So, when we are performing a hypothesis test, there are 4 possible outcomes to this test. The first possible outcome is we reject the null hypothesis, and the null hypothesis is false. This is analogous to a defendant being guilty, and the jury finds that defendant guilty. This is a correct decision. The second possible outcome is that we do not reject the null hypothesis, and the null hypothesis is true. This is analogous to the defendant is innocent, and the jury finds them not guilty. That's another correct decision. The defendant did not commit the crime, and the jury says, yeah, dude, you didn't do it. The third possible outcome is that we reject the null hypothesis, but the null hypothesis is true. So this is analogous to when a defendant is innocent and the jury finds them guilty. So this is an incorrect decision, and when this occurs, we have what we call a type 1 error. So this is where, if you think about the court case, you have your defendant on trial, they did not commit a crime, but the jury sends them to prison or makes them pay the fine anyways, whatever, depending on the severity of the crime, right? Let's say we send them to prison. So this person is sitting here, they didn't do anything wrong, and the jury sends them to jail. That is incorrect, that's a problem. The same thing can happen in a hypothesis test. We can come to the conclusion that our null hypothesis is false, but in reality it was true. The last possible outcome is that we do not reject our null hypothesis, but the null hypothesis is false. This is similar to if a defendant is guilty and the jury finds them not guilty. This is another incorrect decision. This is where the defendant who's on trial has committed the crime, but the jury says, nah, bro, you're good, and lets them walk out. This is what we call a type 2 error. The thing with these types of errors, when you are performing hypothesis tests, is you will not know if you have committed an error. You will not know whether you have actually made a correct decision or committed a type 1 or type 2 error. What you have to know is that it is possible for you to commit these types of errors. And so what we want to do is we just want to try and reduce the probabilities of committing those types of errors. Another thing to remember about these types of errors and all of these things is if I decrease the probability of a type 1 error, I increase the probability of a type 2 error. So I also have to weigh, all right, is it better for me to have a guilty person on the streets or an innocent person in jail? It's not quite that severe because I'm not talking necessarily about people, but you could be if you're looking at medicine. So you really have to decide what is going to be the best decision. And one of the ways that we do this is through this type 1 error. This symbol here next to it, this is called alpha. And we're going to see this alpha value in our hypothesis tests. And this value will change from test to test. If you have a really small alpha value, you are increasing your probability of that type 2 error, but you're also being very restrictive about being able to reject that null hypothesis. So, the takeaway here for type 1 and type 2 error that I want you to know is they are possible, and I want you to know the types of situations where they could happen. So, how do you commit a type 1 error? Well, you commit a type 1 error by rejecting a true hypothesis. So, men actually do prefer chocolate ice cream, using the example from a previous video. Looking at, do men prefer chocolate ice cream more than women? In the reality of the world, the answer is yes, men prefer chocolate ice cream more. But I come to the conclusion that no, that is false. Women prefer chocolate ice cream more. And then, oh, that was backwards. What I just said was a type 2 error. So the type 1 error would be that women actually prefer chocolate ice cream more, but that's not what I conclude. I conclude that men prefer chocolate ice cream more. My theory that men prefer chocolate ice cream, that's what I claim, and that's what I find to be true, but that's not what's actually happening. The type 2 error is the opposite. So the type 2 error would be men actually do prefer chocolate ice cream more, but I don't find the evidence for that. And I come to the conclusion that, nah, it is actually women. Okay, and then just real quickly, this symbol right here, I forgot to mention that. This guy's called beta. They're more Greek symbols. We're not going to see beta a whole lot. We're mostly going to look at alpha. So that's it for type 1 and type 2 error. I just want you guys to know that they're there. They're a part of this process. They are things that we have to consider as we are performing our hypothesis tests. But they're kind of this weird, intangible thing because we won't ever actually know that we have committed a type 1 or type 2 error. We also won't know if we made a correct decision. The only way to know that is to talk to every single person in our population. So, there you go. There are your types of errors.